So let's get rolling with our rollerball. So hopefully everybody was able to get Unity downloaded, installed, a little bit of debugging, blah, blah, blah. I'm going to go through just kind of the first part of this that I got you up that you did for homework, but I'm also going to add some additional commentary in there, that kind of stuff. Hopefully we can get fully up to speed on Unity this week and then start working on our dungeon crawler or extension to that, whatever, starting next week. All right, so for starters, when you go to this rollerball tutorial, it probably would not actually make a difference, but I would select your Unity version for the latest version. So I'll select 2022.3, which is, I think, at least pretty close to what I have installed. All right, so we're going to be starting off with setting up this game. So I'm going to switch over to my Unity hub here. And so most of you should have gone in and you should have some version of Unity installed here, preferably under official releases, whatever the latest, greatest, whatever is. So I have 2022.3.17 F1, which I think is the newest, but whatever. Have something in there. So we're going to go ahead and create a new project. It's going to be a 3D core project. We're going to call this guy Rollerball. And I'm just going to, I store it in, I have a directory already in my, let's say I'll put it in Unity projects inside of that. So just put it somewhere on your computer where you know you can find it. You can leave connect to Unity Cloud clicked. We're probably not going to be using much of that stuff, but you can keep it there. I'm also going to turn on use Unity version control. We'll probably be starting to use that instead of GitHub. Excuse me. All right. So I'll go ahead and click that as well. All right. So I have my project name. It's a 3D core application. I check these couple of things here and I'm going to hit create project. So it's going to go ahead and launch this dude. Now creating your Unity account is free. Up in the upper left-hand corner here. You can go and go to sign in, probably is what it says if you're not already signed in. You know, the upgrade to Unity Plus or Pro, you don't actually need that with your student account. You already have all the features of those things. The only thing that you're missing is if you go to release an app commercially, you're not necessarily covered. So Unity wants a cut. So when you make an awesome video game and you're ready to put it up on one of the app stores and stuff, you can go look at, you know, the different deals for upgrading to Plus or Pro in terms of how they do a revenue share and that kind of stuff. But for right now, we don't need to worry about any of that. But I would get logged in because before long, we might be using some assets from their asset store. There's paid ones and there's tons and tons and tons of free ones, but you'll need to be logged in order to get that. But you don't need to be logged in for this particular assignment. Okay, so let me just close this meeting control dealie. All right, so your initial scene should look like this. You have this main camera thing. If I click on the main camera, it shows you in the bottom right-hand corner here what it would be looking at. So you see the camera is kind of looking out into the scene, and we're going to be messing with the location of the camera and stuff. We also get a directional light, so the scene is lit. But other than that, we have nothing. If I were to go ahead and hit play to run my game, that's my current running game. So very amazing. All right, so we have our project created. We have Unity kind of trucking. So let's go into the tutorial. I'll probably blow past several of the things. Already did this stuff, created the project. All right, so they want us to create a new scene called minigame. All right, so they want us to come up here, and you probably actually don't need to do this because they do give you this sample scene as a starting point, but we'll go ahead and follow the tutorial. We're gonna create a new scene. It's going to, you can create a completely empty scene, or you can kind of give yourself this starter scene that has the camera and the directional light like you've already seen. I'm going to go ahead and hit create there. Initially, my scene is untitled. I'm going to go to down here, my project. And I have, actually, I need to save this. So it's called Untitled. I'll go to File and Save. I'm going to call this guy Mini Game. And I'll go ahead and just put it in my assets folder initially. So by default, you have this folder called assets. There is already a folder called scenes in there. You can put stuff in your assets folder and organize it however you want. It doesn't matter. But since we are dealing with a scene here, we'll go ahead and drag that guy into the scene folder. Just to keep things relatively organized, you're going to see the value in that as we start getting writing scripts and that kind of stuff. All right, so I have our new scene and we've saved it. So now they want us to go ahead and create a plane, put it at 0, 0, name it ground, right? So over here on the left, this is kind of like the hierarchy of the stuff that lives in your scene. So if you right click here, you can see there's a bunch of stuff you can do. You can create an empty game object, and there's plenty of reasons to do that. We're going to be running into that here reasonably soon as we start our dungeon crawler. We're going to be creating a 3D object. So notice there's a whole bunch of these that already exist: cubes and spheres, capsules, cylinders, planes, quads. We can do terrain, trees. So in any case, I'm going to start with a plane. They want us to call this guy ground. All right. And so when you select something over here on the left, it's highlighting it inside of your scene. And notice that over here on the right, we have our, is it called inspector? Or what's it called in here? Yeah, we have our inspector, which shows you the information about your current scene. All right, so now the very first thing we want to get in our notes here, though, is this this concept of something called a transform. Uh, Actually, let me start with game object. So this thing is anything that lives in our scene, whether it is visible by the user or not. All right, hence the idea of that empty game object. All right, so a game object is the kind of, you could almost think of it like when we talked about Java, the top level object in Java is called object. Game object is the top level thing in Unity. So everything inherits from game object. So this is as close to nothingness as you can get. All right, so we have this game object. Now a game object has very little stuff in it. So if we look at, you know, if I have a, here, I'm just going to quickly create an empty game object over here. So this is a completely empty game object. But notice a game object does come with something called a transform. All right, so all game objects have a transform. And a transform keeps track of three things: location, you can think position, scale, and rotation. All right, so 3 pieces of information, each one having 3. So this is X, Y, Z. Y, Z, X, Y, Z. All right, so 3 pieces of information about 3 different things. Okay, so position, rotation, and scale, X, Y, and Z for each of these. So this is the position in 3D space across the X-axis, the Y-axis, and the Z-axis, that's going depth-wise. Rotation, we're not going to, well, actually, I think you do maybe deal with it somewhere in this tutorial, but rotation is one of those things that we're going to be pretty impressed with Unity helping with us, because helping us with that, because the rotations inside of Unity are done with a kind of a mathematical concept called a quaternion, and quaternion mathematics is not necessarily friendly mathematics. But the good news is Unity does it all for us. And then also scale, how big is it on the different planes. Now, this empty game object I have here is completely empty, so we have no way of seeing it on the screen, so it doesn't even matter where I move this guy to. It's not part of the game, really. It just exists, and there will be examples where having something just exist like that is actually handy. All right, so I'll delete that, go back to my ground. Notice that the ground does have a transform, but it has some other stuff in here. One of them is a mesh filter for being able to see the plane, a mesh renderer. Well, that's actually, mesh renderer is what actually puts it on the screen. A mesh filter is what sets it up to be put on the screen. We have a mesh collider. Colliders in Unity are used to have objects bump into other objects and for us to be able to respond to that. So this guy's going to be the ground. So eventually we're going to have something sitting on the ground. And just like when you walk outside and stand on the ground, you want to not fall through it. So you kind of rely on the fact that your feet collide with the ground and that stops you from falling through it. All right, and then we have this default material, which everything right now is this white color. We'll be changing that. All right, so now in the, what does it want us to do? It tells you to press the F key to select something. The other thing you can do is just double click on it. So if you double click on it, it'll kind of center it on your screen. You'll also kind of get used to using this guy up here. If you want to look straight down on it, you can click on the Y, look on it at it from the X side, from the Z side. My trackpad is a little bit rough for doing this rotation with, but you'll get used to kind of maneuvering around the scene as you go and start messing with that kind of stuff. All right, so what does it want us to do with this dude? Wants us to scale the ground, X and Z to 2.0. All right, so click on ground, we have that selected. Now, notice over here on the left-hand side, we have several different tools. We have the movement tool, which is the one that's currently selected. That's the one that has the arrows coming off of the X, Y, and Z. We have a rotation tool, so that gives you the X, Y, and Z for rotations. So you can start messing with those. Sometimes it's easier when you want something to rotate in a certain direction. While you might want to ultimately come over here to the right and put in precise numbers, just so you know which thing you're just to make sure you're doing it on the right plane. You might decide, okay, well, I'm going to start rotating it this way. And then you notice, okay, that's about the Y-axis. So I can rotate it 90 degrees on the Y-axis if I want, that kind of stuff. So sometimes you can experiment with the scene itself to kind of make sure that you're changing the correct thing over here. We have our scale tool. This is the one they told you to mess with, where you can kind of drag, the thing out on the various, the various axes. At the end of the day, you probably would just come over here and put in 2 for X and 2 for Z. And now that gets you what they asked you for. So there's several different ways of kind of accomplishing the same stuff as you go through here. And just through practice and trial and error, you'll kind of learn that sometimes you use them together to kind of accomplish what you want to accomplish. What's kind of fun with using Unity after you get past the initial learning curve is you kind of get to experiment with some things, and sometimes you'll accidentally bump into some cool effects just from playing with it and messing something up, and then all of a sudden it actually behaves in a way that's even better than you were expecting it to. So playing around with the physics engine is actually kind of fun for a while too. All right, so we've scaled that to 2.0. Now they want us to create a player game object, and that guy is going to be a sphere. So we'll come over here, we'll right click, we're going to create a 3D object of type sphere. We're going to name this guy player. Now, if I go ahead and double click on this guy, notice that here's my player. We zoomed in on him. It's currently sitting. Actually, it's probably halfway submerged in the gotta see it. It's dipped down in that plane. That type of thing. So, we're going to be moving that so it sits on top of the ground here pretty soon. Make sure you put the player at the origin 000. It's already there. We can kind of tell that by just seeing that everything is kind of centered in the middle of the scene. You can test it by clicking player, seeing its position as X, Y, and Z is 0. So is ground. So the center point of any 3D object is the middle of it, as opposed to some other game engines might have the upper left-hand corner being 0. So just kind of whenever you're working with any sort of 3D tool, even 3D modeling tools like Blender, one of the first things you want to find out is where is 0. Is it center? Is it upper left-hand corner? Is it a bottom left-hand corner? Whatever it is for that piece of software here in Unity, it's the center point, which probably makes reasonable sense. So that's fairly intuitive for us. All right, so now we're going to move the player on the Y to position 0.5. So we're moving it above the ground. We can kind of see that if we want, if we just go to the arrow here, click over on the X or the Z. I go ahead and zoom in a little bit. We can drag this guy up, except I have the ground currently selected. We can drag the player up, and we see now it's above the ground. And we see we get a shadow off of it from the light source up above. They want us to put this guy at 0.5, which makes sense since the scale of our sphere is 1 and half of it was below the plane. Putting it to 0.5 positive on the Y moves it up half of a thing. So now we're sitting right above the plane. Okay. We can adjust the default lighting. So we can select the directional light. And then they want us to do what? Expand the emission module to be color 255, 255, 255. So we'll go ahead and select directional light. We'll go into, where is emission? Use the fold out, trying to expand the emission module. Use the color picker. Well, here's the light. Is there emission in here? Do not see emission. So whatever, I'm just going to skip that for now. Maybe we'll bump into it later. They were probably changing it to like a softer white or something like that. All right, so now they want us to add some colors to our scene to differentiate our player from our ground. All right, so we're going to create a couple of players. You can change them to whatever color you want. They're having you set it to RGB 130, 130, 130 for the was that for the player for the all right, well, let's just do it. So we're going to go ahead and create a materials folder. So again, we want to stay fairly organized with our assets here. So we'll call this guy materials. So we'll go into the materials folder. We're going to create a new material. And this material, we're going to select base map. So we're going to right click, create material. All right, so we have this guy here. Now they want us to expand the surface inputs module and select base map, color picker. So metallic thing that they were talking about. I usually would just select the albedo thing here to ultimately get a color. So there's kind of a goldish color. You can mess with these guys to give you the actual number. What I say, 130, 130, 130. $30, 130, 130. So whatever. It's kind of a reddish. And then they want us to be this this guy right here. I'll call that close enough. All right. So we have a gray material now, and they wanted us to give it a metallic map for smoothness. So you can sit there and mess around with your so what is this? A 0.25. They wanted it. So you can mess around with the colors, getting it looking the way you want. We're gonna, kind of blow past that reasonably quick. All right, so that was for background material. Then we want a player material. So here we're going to call this guy background. Then we're going to create a player material. So another material here. Call this guy player. And I'm just going to do my usual thing here. So I'm going to click there. We're going to decide that our player is going to be that color red just because. Then we're going to have a ground material. So we're going to create material, call that guy ground. And we'll make the ground, I don't know, this kind of tealish color. Good enough. All right. So now a couple different ways you can get this stuff on there. So on one hand, if you click on one of our objects like player, by default, we have this default material on there, but we can go ahead and we can either remove this material, or I can say I want to add a component. I can say I want to add actually we need to update the material that's already on there. Rather than do that, I'm going to take my player, I'm going to drag it onto my player. Now, when I do that, you see that the player's default material has been updated to this new material we created. And you can mess with shaders and stuff like that. Drag the ground out there. I'm not sure where we put the background. It's probably at this top level here, maybe. I don't know. Let's keep rolling. All right, so we got a couple things that are a couple different colors now, so we can mess with that. We can change the light's rotation if we want to have it pointing in a couple different directions. If you notice here, if I have the light and it's currently going that direction, and I change its rotation. I just start messing with it a little bit. You see that the shadow is changing, so you can decide what makes sense for your scene. I'm just gonna kind of leave it at something. As we start writing it, and we're moving around, if the shadows don't look right or the lighting isn't good, we'll just move the lights around and things like that. Then, all right. So is that the end of setting up the game? So now we want to get and start looking at scripting. So we'll go to moving the player. All right, so now we start dealing with some of the physics things that are involved here. And the first thing that we want to think about here with the physics stuff is something called a rigid body. Rigid body. So this is a solid object that has mass and potentially gravity. We'll call it amongst other things, but basically, if there's something in your game that you want physics to behave on, it's something more than just something you see, but it actually can bump into things and stuff like that. It's got to be a rigid body. It's got to be something that you would think of as being a solid object in real life. And we make something a solid object by making it a rigid body. All right, so right off the bat here, I'm going to click on my player. I'm going to go ahead and add a component to my player. And I'm going to add a rigid body. Make sure you do rigid body, not rigid body 2D. I think I'd mentioned in class last time that many, many years ago, Unity added some 2D game design stuff into it to allow it to sort of compete with programs like Game Maker and stuff like that people used to use for making platformers like Mario Brothers and Mega Man, that kind of stuff. So you do have some 2D versions of things kind of floating around in here, but I would say largely people use Unity specifically for doing 3D games. All right, so we're going to make that guy a rigid body. Now notice here that I have gravity turned on by default, which means that this guy has gravity impacting him. All right. So right now, notice that he is sitting on top of the ground. Why is he able to do that? Because the player came built with a sphere collider, and the ground came built with a mesh collider. So these guys know how to collide with each other. If I go to my player and I remove the sphere collider, so notice I still have my game running, and I just disconnected that. I just disabled the sphere collider. We saw our player fall through the floor because the colliders are no longer bumping into each other. But when I hit stop, notice it comes back. So a little rule of thumb, make a note of this somewhere. As you start using Unity, one thing you'll bump into is sometimes something's not behaving the way you want it to behave. So let's say I started running this and I expected my player to fall through the floor for some reason. I might come over here and start messing with some stuff just to get things in the right location or the right settings or whatever. But if the game is currently running and I make a change here, that change gets undone as soon as I stop the game. So if you want those changes to be permanent, make sure the game is not currently running when you make that change. So now I turned off sphere collider. So now when I run this, he'll fall through the ground and the sphere collider is still disabled. Okay. Now we can kind of see these guys bump into each other if we want. If you want to take our player, move him up into the sky, you can kind of have him drop into the scene. You've actually seen this if you want to think back to this mechanic in a lot of old platformer video games. Getting 3D objects or even 2D objects to sit pixel perfect on top of each other. So right now we just use the math to move it at 0.5 to be above the ground. But what you would have in some older game engines or even prior to game engines is they would actually just start the character. So one of my favorite games when I was younger was a platformer called Mega Man. And Mega Man would always start kind of like 5 feet above the ground and he would drop into the scene. And the reason they would do that is to create that impact with the ground to get him placed perfectly on the ground. So kind of an old trick of programming, although we can pretty much do it with math and stuff now. But one thing we'll see, let me just move him back down to 0.4. All right. So now he's at 0.4. So he actually is slightly sunk into the floor. Okay. So you actually saw Unity correct for that. He actually bumped back up to that half thing. You notice he's at 0.5 now. So maybe we'd have to sink him down a little bit more. See at what point it won't correct for us. Oh, maybe it corrects up to halfway. Yep, looks like roughly halfway. So it'll push it up to get above the thing if you have it greater than halfway above, but realistically, you can just, position it whatever you want. But that allows you to kind of drag something like this, hit play. You can look up here and see, okay, it ended up at 0.5. So now you can just remember that. One thing you can do is, let's say you get the settings over here just the way you want them. You can go up to these 3 dots and you can say you want to copy. You can either copy the entire component, or in this case, I want to copy the position. So then when I turn this off, notice the position is back to the 0.41. I can go into here, hit paste and say paste position. And now it puts in that thing I did. So that kind of makes you remember that when the game is running, any changes you make over here in the inspector are not permanent. But if you end up liking those changes and you want to be able to make them permanent, you can copy them during runtime. And then when you stop it, go and paste it over. Okay. So we have some different colors. We added a rigid body to our player so that gravity can have an impact on it. They want us to install the input system package, which is a stupid way of doing movement, but that's okay. We're still going to get into the scripts. We're going to be writing scripts here reasonably quickly anyways. So we want to install the input system package. We want to go to Window Package Manager. So Window Package Manager. Probably want, is it in this list or is it under all? Let's see, what does it want us to click on? Packages drop down, select Unity Registry. So under packages, Unity Registry. And we're going to have input somewhere down there. Input system package. So I guess scroll down till you get to something called input systems package, input system. All right, so I click that, go over here and hit install. This is going to add a plugin to our scene. Historically, we would have just used the code for the arrows and stuff, but we'll actually see this. And let's see, warning, uses a new impact system. It's not enabled for player setting. This means that no input from native devices will come through. Do you want to enable the backends? Doing so will restart the editor. So let's say yes, we want to enable that stuff. So we'll go ahead and save our project, let it restart. Oh yeah, so it says it's, hit yes. So we just did what it told us to do. So we just restarted. Now we're going to adjust the build settings. It says this for Windows only, but I'll go ahead and go into it so everybody can see it, because I'll point out a couple of things in there. So if we go to File, Build Settings, This is related to something I talked about in class last time. So if I go to File and I go to Build Settings, you see here over on the left, the platform we're building for, you can either choose Windows, Mac, Linux, because it's actually running on top of the Unity runtime. So then you can choose your target platform in here. You can choose your architecture. So right now it's set for Intel as well as Apple Silicon. I'm on a machine that's just Apple Silicon, so I could change it if I wanted to. I'll just leave it to the default. This Xcode project thing has to do with Apple development stuff. So in any case, you would change yours to make sure your target platform is whatever platform you're on, Windows, whatever. Notice here that I had mentioned that if you want to write Android applications or VR app for the Quest, you would use Android as your target platform. And then you can turn on some VR stuff and things like that. Notice I also have Vision OS experimental put in here. So I mentioned that the Apple Vision Pro comes out on February 2nd. You can use Unity to develop for that as well, as opposed to using Apple's built-in tools. So this is kind of a place that you would go when you need to change up what you're going to build your game for. So imagine that you're writing, so notice you can do Android as well as iOS. So imagine you're writing a mobile game for smartphones, and you originally, let's say you are an Android user and you have an Android phone you want to ultimately test it on. You could test it in the simulator here in Unity, but when you're actually ready to deploy it on your real device, you would click it to Android, you would do a build and run. So it's, your device would show up here if you had it plugged in. And you do all your testing and stuff that way. But as soon as you're ready to also build it for iPhone, all you would do is change the build setting here for iPhone. And I don't have it installed on here, but you would install the iPhone software and stuff. And then you would do build for that. So now you can upload it to the Apple App Store. You don't have to rewrite the project to work for Apple or Android unless there was some very specific feature you were using in the Android or the iPhone version that was only available on one of those two packages. So for example, when we do some Vision OS stuff, there's going to be things that don't exist on iPhone for Vision OS. So if you start putting some of those things into your application, deploying that on iOS for iPhone is not going to be a successful endeavor. All right. But what we're learning here is the skill set of using Unity. Deploying it to any of these things is just a matter of going into these build settings and making those changes. All right. I'm also going to go ahead and just click Add Open Scenes here, because initially we had the default scene, but we added that new scene, so called mini game. So I'm just going to say Add Open Scenes. That'll put mini game here. So that means if I were to build this and put it on a device, the scene that it starts with would be the mini game scene. It would also package any other scene I have in here. All right, so I'll go ahead and close that dude. All right, so it's telling you for Windows people, make sure you have your architecture set up as this is Intel 64-bit x86. x86 is an Intel-based thing. Yeah, so all of you who are on a Windows machine should be able to set that. This is also compatible with AMD. If you have an AMD processor, it's possible they have an AMD specific setting, but I bet you this would work anyways. Sometimes you might need to tweak with it a little bit. So anyways, that's what's in build settings. Okay, so now we're going to go into adding player input. So we're going to select our player game object and go over from the hierarchy, and we're going to add something to it. We're going to add a component called the player input component. So we'll select our player here. Make sure the game's not currently running. That's a mistake I make all the time, is I do all this stuff and realize the game was running, so then it gets all undone. So I'll hit player. I'm going to come over here to the inspector. I'm going to add a component, and I'm going to go to player input as the input or input manager, player input component. So here's my player input component. Okay. So that's kind of, this is kind of the cadence of using Unity, is you have game objects that you can then attach components to, and then you let game objects know about other game objects and things like that. You're going to see through this tutorial, you build up kind of a core set of Unity skills that we're going to be able to immediately apply to a whole bunch of different things. All right, so you're not really learning about the rollerball thing, you're learning about more about controlling a character, writing scripts in Unity, this kind of stuff. Okay, so in the component, we're going to say create actions. We're going to create a new folder called input, so we stay organized. Okay. So let me go over here and let me create a folder called input. Click on player again, scroll down, and the thing it wanted me to said it wanted me to do select create actions. Create actions right there. All right, and we're going to put this inside of our assets folder, specifically inside of my input folder I just created. Again, it doesn't matter if you want to have everything just strewn about in your assets folder, you can. Unity doesn't care. We're just going to try to stay organized ourselves. So we went ahead and did this. I'll go ahead and mention again that I'm not necessarily a huge fan of this input thing because it delays us getting into the scripting, but that's only going to be temporarily, so that's not a big deal. Okay, so we although I didn't rename it input actions, that's fine. Okay, so if the input windows, you can close the window now. All right, so now we're going to create a script for this player controller. All right, so I'm going to start off. I guess I'm just going to close this for right now. I'm going to go ahead and create a folder in here for scripts. And I'll go into this folder. And now I'm going to create a C# script. I assume they want to call it player controller, maybe. Yep. Okay. A lot of times we use the naming convention controller when we're writing a script that's going to control something. So in this case, we're going to write a script that's going to control the player. Okay. Now we're going to open the script in a script editor. So when you installed Unity, by default, it installed Visual Studio on your computer. You can, let's see, where is it up here? Is it under build settings? There's an external tools thing somewhere. If you want to change what program launches when you double click on something. It's in one of these things. You can change the external tool that launches if you want a different program, a different text editor to launch. So I'll double click on this guy. Notice it's launching Visual Studio, which should be your default behavior if you installed Visual Studio with Unity, which I think is the default. I think that's already selected for you. All right, so it opens up a file, player controller.cs, like we have here. Okay, a couple things to look at first. First of all, we are looking at C# code here. And right off the bat, it shouldn't look that foreign to you relative to Java code. All right, so a couple of points of interest here. This little colon here in Java would say extends. It would say that. This is inheritance. All right, and this is kind of an important piece here. We have this thing called mono behavior. Let's go back out to the notes. All right, so mono behavior is a class built into Unity that inheriting classes, well, let's say that classes can inherit from, to get the behavior of the game loop inside of the game objects. Right, we're not always going to use this, but initially we are. But as soon as we start doing our dungeon crawler, we're going to have some normal classes. We're going to be converting our Java dungeon crawler classes over to C#, and those are not going to be mono behaviors. All right, those are going to be things that they're going to be effectively acting as data structures, keeping track of the current state of our dungeon and stuff in code. And then we'll make our user interface, our 3D model of our dungeon or whatever, mimic what the current state of it is in code. All right. So with a mono behavior, there's several built-in functions. The two they give you by default is something called start and another one called update. Start is a function that runs once when this script is first instantiated with a game object in the scene. Okay, so this is where you can kind of think of this kind of like a constructor. Okay, this gets called one time and it's when the script is first instantiated. So if you want to do some initial setup stuff inside there, setting up some fields, things like that with some starting values, you would maybe do that inside of start when you want something to just happen at the very beginning. Update. And then I'm also going to put in parentheses here. There's another function called fixed update. This involves the game loop. Update runs every single frame, while fixed update runs 60 times per second. Okay, it's kind of maybe an important trade-off. I've referenced a couple different times in class, whether it was last semester or this semester, kind of the purpose of getting these expensive graphics cards and things like that. When somebody is a PC gamer and they buy these expensive graphics cards that might be able to drive your game at 400 frames a second or something like that. In certain games, if you're having that kind of response time, you might have an unfair advantage over somebody who's only going at 30 frames a second or something like that. So depending on the game you're writing, you might decide you're going to use a fixed update, which says we're going to do the best we can to give everybody an equal experience. So if you're running your game at a frame rate less than 60, you're kind of screwed, let's say. But if you are running your game at least 60 frames a second, then you're on an equal playing field with 60 frames per second versus 400 frames per second, because the game loop only updates 60 times every second with fixed update. Whereas with normal update, it updates every single opportunity it has to update on whatever machine you're currently running on. So if it's running at 400 frames a second, that means 400 times every second that update function will get called, and things you put in there will update. That deals with the movement of your game objects across the scene, checking different stuff. So you do want to kind of consider what you're putting inside of update to make sure that's the appropriate place for it. Or make sure you don't need to do it as an asynchronous action like we've been talking about threads. We have something along those lines in Udemy called coroutines. Because the reality is if, let's say you have something inside of update that takes 30 seconds to do. I'm just kind of using an extreme example. That means you're going to start something that takes 30 seconds to do every single frame, which might happen 60, 70, 80, 100 times per second. depending on the game. All right, so you kind of get to decide. Initially, we just put everything in update because we're not really worried about fairness in our games and stuff. And every time it can update the scene based on how good your graphics card is, it just will. Okay, so I'm gonna leave it off there for right now. What we're going to do for next class, I think for this one, I had you go through setting up the play area, right? Um, so I think what we'll do for next class is the creating collectibles and then detecting collisions, just these next two. And then over the weekend, I'll give you the last part. So if you want to just get ahead, you can do that. Because like I said, I'm going to be dragging a little bit behind you on here because I'm filling in some gaps as we're going through this. All right, so for homework for Friday, the next two parts of the tutorial, which is creating collectibles and detecting collisions with collectibles. All right, because we're going to be driving our guy around picking stuff up. All right, questions, comments, concerns, bribes. All right, I will see everybody on Friday, hopefully back in person.
Dr. Littman.
Hi, Mr. Lemon. Have a good day.
Yep. What's up?
So during class, I just installed a new one,
Yep.
a new version, and I got it running.
Okay.
So I was just wondering if on Friday I could just turn in like all 1 through 6, so I could just do
That's
that
fine.
all together.
For now, just submit a note with the one that's due today, just saying that you had a bug with Unity and you're gonna to count the next one twice or something like that. Just give me a
Okay. All right.
reminder for that.
All right. Thank you.
Yep.
Also, I think it's an older version, but I mean it's getting the job done, and from
Yeah,
what
it
it seems, it
should be
looks like
fine.
it has all the stuff to
I
do.
don't know why it would have been a problem, but that's
Yeah,
sometimes
I don't know either.
quirky things, but it's fine. I think it'll work.
All right. Yeah, I'm just glad I got it working.
So, all right.
All right. Have a nice day.
Yep. Take care.
You too.